Thank you, everybody. Thank you, Bertrand, for this such an inspiring talk. Thank you for all of you guys for coming, making it here. It was not easy. I talked already about how excited we are to combine the Schlumberger, Station F, and ecosystem startup work together today. This is how we started Celsius, actually, trying to leverage on what our expertise is, right, in Schlumberger, and see what we could do in the energy domain, right, something a bit different. And so we were like, okay, what can we do? And the founding number that struck us was 50%. 50% of the world energy today is not used for lighting, not used for plugging, is not used for mobility, car, planes, or so on. 50% of the world energy today in the world is used for heating and cooling. Heating our industrial processes, but mainly heating our houses, our offices, our commercial buildings. And this is something that is kind of vastly ignored, right? At least we didn't know how much it was. And all this heat today is mainly comes from fossil fuels, burning fossil fuels, gas mostly, fuel, coal in certain regions of the world, emitting lots of CO2, contributing largely to climate change. Energy transition is on. Energy transition is there. Bertrand explained it much better than I would do so. Energy transition is there, especially here in Europe, and we see a trend, that maybe that some of you are very aware of, some may not be as exposed as us, European. In some country today, when you are building a new building, right, you cannot connect it to fuel, to coal, and now in some countries, you cannot even connect it to gas, right? This is something that is ongoing. And you have public policies that are smoothly, gently moving forward. And you also have private corporation, private company that go even faster than the public policy, really contributing to the energy transition. Here, thank you, Bertrand, for the good introduction. We're talking about the building industry. We're talking how we can contribute to make this industry a cleaner industry and building cleaner buildings, cleaner assets. The energy transition for building happens in 2 steps. Step 1, you monitor your data. Yeah, we know we are engineers there. We monitor the data, and we can save the amount of energy, reduce the amount of energy, be more efficient in the way we're heating and cooling our buildings. That's the first step, right? In Europe, we estimate that there is more than 20,000 buildings every year being renovating for more thermal efficiency, reducing the amount of energy used. Now, step 2. You have remaining energy. How can you source it differently? And this is what we're going to talk here. Step 1, you reduce. Step 2, you source it differently with a less carbonized source. And here we want to talk about an opportunity. Every building, would that be here in London, München, wherever in the world, 70% of the energy that a building needs is actually readily available underground. And this is where Schlumberger expertise comes. So every building, you have the energy that you need to heat it and to cool it, to AC it, just under your feet, a few hundred meters down.
So collecting heat from the ground is something that we know of and that we call geothermal. And I'm putting here a few numbers, right? I've stolen some stuff from Storengy, our friends in France. And they describe fairly well the different kind of geothermal we can look at. On the right, we're going down, and we're going to fetch very hot water to generate at surface electricity. That's geothermal for electricity. In the middle, we have district heating. So we go down again, and then we fetch quite a lot of hot water, 70, 80 degrees C. That's going to be routed in pipes around the city to directly heat the buildings. Paris is actually quite popular for that. Right here in Station F, we're heated on Heat District. And there's about 80 of those quite deep wells around Paris to generate some of the heat. And that, at Schlumberger, we know it. because that's drilling deep. That's the same stuff as drilling for oil field. So we're involved in that. But now there is something different, which is shallow geothermal, or ground source heat pump geothermal. And this is really about drilling shallow wells, about 100, 200 meters in the ground, collecting enough heat, and then with the help of heat pumps, supplying heat to buildings. So when we started to look into that, we said, okay, we're going to drill shallow. And a lot of our Schlumberger friends, they had a laugh at us because they said, well, it's not really drilling, right? It's 200 meters. It's more like gardening. So, okay.
We do
stepped
gardening.
aside, but we like gardening. We're going to stick to it. So we looked into that, but then we pulled a few numbers. And the first one that you see on the bar graph is very important. If you look at the amount of power that is generated today in Europe, the shallow geothermal far outweighs the other kind of geothermal energy. So it's very important. As well, when you look at the drilling distance, in Europe alone, every year 22,000 kilometers are being drilled. Hey, it's gardening, but it's getting massive gardening, right? And if you count the dollars, I'd say it's probably $1.5 billion of that drilling revenue that is taking place everywhere in Europe. In the world, we think it's 60,000 kilometers are drilled every year. So it is a business that is a bit out of our radar, but still important. And a business that obviously, because it's renewable, is growing, and is growing fairly fast. So we haven't actually invented geothermal. It exists, it's there. The one country in Europe where it's mostly popular is Switzerland. And we'll go back to Switzerland. Iceland, of course. Yeah, it's too easy in Iceland. But when you look at a building, and if you look at a fairly large campus, let's say Clamart, our SRPC site in Clamart. So we looked at it, we looked at the amount of heat and climatization that is required, and it's massive. But to be able to collect the heat, we actually need to drill many wells. In the case of Clamart, it's 70 wells, and we need to space them apart from 10 meters from each other. So at the end of the day, to make it work, you need a football pitch. That's 70 sound. So in Clamart, we almost have it, right? Big parking, some gardens and stuff. But in our dense urban city, it's not available. So that's a very strong limitation to current geothermal solution. And that's why with Celsius, I think we've cracked at least one of the barriers. So with Celsius, what we want to do is to start at a single point, close to the building, where the energy is going to be needed, and drill deviated, slanted wells, an array of wells, so that down in the ground, we actually take that football pitch. But at surface, during the work, we actually need a few parking spots, 100 square meters. They are always available nearby buildings. And once the work is complete, the drilling rig is gone, we only have a very, very small footprint where all these pipes come to surface and we can connect them to the building. So this one is a bit about technology that we use in a simple format. Different elements that you find here. The first one are those wells, deviated, and we're going to be circulating cool water in the ground in a huge tube. So we'll send it cold, and we'll get it hotter because the ground gave the heat to the water that we want to use. We'll collect all that thermal energy in the form of hot water there, and then we will send it inside the building to the heat pump. So heat pump is a beautiful technology. And we'll crank up the temperature to the temperature that is required by the building. The efficiency of those systems is absolutely great because you can use 1 watt of electricity at the heat pump and deliver up to 6 or 7 watts of heat to the building. The other 5 or 6 coming freely from the ground. So it's extremely efficient. The other big advantage is that it's reversible. So in the winter, when it's cold, you need to supply heat to the building. So you will actually extract the calories from the ground and supply them to the building. The other way, when it's summer, you actually need to cool down the building. So you pull the calorie from the building and you send them back down in the ground. And the ground is very good because it has a lot of thermal capacity. It can store energy. So that cycle of taking the heat, supplying it to the building, sending it back down in the ground is very efficient. So now we looked a bit into the differentiators that are needed to make it successful in that business. The first thing is that, for sure, we know something about the ground. We know something about drilling. We're in our world, right? But to be successful in that business, we need to build up partnerships with people that have the technology. And I'm putting here a picture of a heat pump. That's the kind of heat pump that will be needed for Clamart or industrial scale building like here. We need as well to partner with people that are in that business today, the people that are supplying solutions of heating and climatization to buildings, because these are not our today customer of Schlumberger. So that's why we partner with those guys to be able to run that business successfully. What we've done was to as well build a full thermal avatar, digital avatar of the building, of the ground, of all this interaction that I was describing. And we've invested a lot of efforts using the best scientists that we have internally to fully model that. And finally, to be successful in that business, the core of the cost still comes with drilling. So it's amazing the amount of technology that we have in Schlumberger, that our day-to-day life in drilling, that we can take into that industry, which is today very artisanal, let's say, to bring the efficiency there, and then be competitive on cost, and then be successful in that business.
So partnership, efficiency, modeling will help us put together the economical equation to be profitable, to have a solution profitable. And with Celsius, what we do is we reduce the OPEX associated to the heat and cooling of the business by 40%. We save energy, really, by 60%, and we eliminate 90% of the CO2 emissions for a building. And this is true for any building in dense area, wherever you are. Would that be in a camp, in somewhere in Luanda, or in London for an HQ, or even in the Netherlands somewhere? And so the idea is to actually do it. And I think we should have a little bit of music there. So what the right place to test the technology was our Clamart Center in SRPC. And what we're doing here, so Clamart is a 20,000 square meters of campus, heating today by gas, 40 years old gas boilers. And we thought that it was exactly the right place to test the technology. So what we've been doing, bringing all the technology together, and we start drilling 3 weeks ago, 2 first wells. One. We started that, it was 3 weeks ago, and that was exactly the right occasion for us to capture all drilling efficiency, NPT, all we know how to do in Schlumberger, to know what is the margin of improvement and optimization that we can bring to this industry.
And what you see here is actually an industry first. That industry has never drilled except it vertical. So we asked those guys, actually a Swiss company, to come and slant the mast. So a lot of discussion, but the first time we did it. So actually we drilled that second well. We actually drilled it much faster than the first vertical one. And we've shown that it was possible then to create that Celsius pattern at surface. What you see here is the completion. So we're lowering those plastic tubes that are going to be buried 200 meters in the ground. We've put a bit of our Schlumberger technology here as well, put a few optical fibers to precisely monitor the temperature that we have in the ground. And as we speak, as of today, the drilling is complete, but we monitor the thermal response of those wells to be able to fully design what we want to do, which is going to be the full campus next year. We're going to be drilling 50 wells and then fully retrofit that campus with a green source of energy.
So this is it. We are ready for phase 2. It's going to be next year. And the idea is not just to retrofit Clamart, our campus. The idea is to scale it up to any type of building. And to do that, we have a team of technical experts from Schlumberger and from the outside, because we do not know everything, right? We have to recognize, to acknowledge that. And we are also supported by the business schools here in Station F to make us a sound and economically viable product and business.
And what we do as well is that we talk to a lot of potential customers, clients. We're discussing with Pathé about a movie place that they have in Lille that they want to build. And we discuss with them to try to make it work on geothermal. We discuss as well with other big construction companies that are obviously very much as well have challenge about energy transition and like the idea that we bring on the table. So this is a lot of effort and a lot of things we want to do, because the idea is to take it outside of only a Schlumberger campus into a real business.
So we have invited here, just behind you guys, Schlumberger, that we are discussing with and we're working with today. And you guys as well, right? You own your own building. You can make it green as well, so we can discuss it anytime. And we're ready now, at the cocktail, whenever, and we discuss your use case. Thank you very much.
Thank you.